So now we're going to look at focusing. Whenever you look at a page, there's light rays that are coming from the sun or from a light in the room. It's bouncing off the page, and the light rays then are getting into your eye and they're hitting the retina, and then your retina is converting that into impulses that go to your brain and you see an image. So it's all to do with light rays and getting them focused on the back of your retina. So if you were to look at, let's think about the eye. So if that's the choroid inside it, we've got the retina. We're not going to worry about the sclera or anything like that. We've got the lens. We've got the cornea. And we've got the conjunctiva just outside there. So whenever the light rays, when you see something, there's light rays coming into your eye. They pass through the conjunctiva. Now, you might remember in physics, if you had a lens and you shine a light ray at it, instead of coming out at that angle, it'll bend a little bit. The thicker the lens, the greater the angle of refraction. Okay, so that's a greater angle than that. The thicker the lens, the more, we go back to what we were looking at there. The light in the top diagram here, the light passes through the conjunctiva, the cornea, through the aqueous humor, then through the lens, and it gets refracted and it hits the retina. Same time, there'll be other light rays coming out at all sorts of angles, and they have to get refracted and meet up at just one clear point on the retina. That's what your eye is trying to do, trying to focus all those rays that are coming from the same point so that they make just one point on your retina. Now, I haven't drawn an awfully neat diagram, but hopefully you get the idea. Now, when we think, if we look at the top diagram, the only thing that can actually change shape or thickness in your eye that we've talked about so far, well, it's not the conjunctiva. The cornea does a lot of the refracting or bending of the light, but it can't change thickness. Then we've got the aqueous humor, then we've got the lens, then we've got the vitreous humor. The only thing that can change or that can be changed in thickness is the lens. And we know that it's connected by suspensory ligaments to the ciliary body, and the ciliary body contains a muscle that can act on the lens. So we're going to look at how that might happen. If you're looking at a distant object, the light rays come into the eye, if that's the eye, and we're miles away or lots of... The light rays are more or less parallel, so they don't have to be bent an awful lot. If we look at a point that's close up to the eye, the light rays do have to be bent more. So what we're saying is a distant object the rays are almost parallel. So we'll say light rays are parallel. So there's very little refraction or bending needed. So if I just rub this out in the bottom corner, if we look at that again in more detail, there's our distant object. The light rays are coming and they're more or less parallel. We need very little refraction for them to be focused on the retina. So we want a lens that is long and thin. So we said the lens is surrounded by the ciliary muscle that is inside the ciliary body, and it's attached by suspensory ligaments. So what actually happens is the ciliary muscle, well, as you can see, it's circular muscle, it relaxes. So if it relaxes, if that's a muscle, circular muscle, and it relaxes, it gets bigger. So this ciliary muscle actually gets bigger. So if I rub this out, so it's relaxed. And that pulls on these suspensory ligaments, it pulls them tight. Now the word that a lot of textbooks use is taut, T-A-U-T. It means it really puts them under tension, it pulls at them. That tension is transferred to the lens, and the lens is actually pulled outwards. So if you imagine in the top diagram here, if this is pulled outwards, the lens changes shape and becomes longer and thinner. So I summarize that, and you could actually jot this down. So when you're focusing on a distant object, the light rays are parallel. So ciliary muscle relaxes. That pulls the suspensory ligaments hold on. Not quite sure what's going on here. Suspensory ligaments are pulled tight or taut, and that makes the lens long and thin, longer and thinner. Therefore, light rays are only refracted a little. I've run out of space. Okay, so we said the light rays are parallel, ciliary muscles relax, that pulls the suspensory ligaments taut, which then pulls the lens to make it longer and thinner, therefore the light rays are only refracted a little. And that's grand because that's all we need. On the other hand, if we look at a close object, there's our close object. Light rays, let me see. Light rays are going to be needing, they have to focus on the one point so we get a clear dot. And so there needs to be a lot of refraction there. So we need more refraction, so we need the lens to become thicker. And the way for that to happen, there's our lens, there's our ciliary body. The ciliary body actually contracts and squeezes in, and that pushes, well, it puts pressure on the lens and the lens bulges out. So if you were looking at it from the side, it started off like that and it ends up like that, with the ciliary muscles initially, ciliary muscles here and here, attached by the suspensory ligaments. But now ciliary muscles are right up against it, and the suspensory ligaments they're still attached, but they're loose. When we're focusing on a close object, we say that the light rays, well, we saw in the diagram, they look like that. We say that the light rays diverge. In other words, they go outwards, they spread out. So, the ciliary muscles contract. And as a result, the suspensory ligaments are loosened. The lens becomes shorter, but the important thing is that it's thicker. So it's thicker, so the light rays can be refracted more. Okay, so just to recap, the light rays from a close object are diverging. As we said, that means that they're spreading out. We've said that they need to be refracted more to focus them on the retina, and so we need a thicker lens to do that. So in order to make the lens thicker, the ciliary muscles contract, so they sort of squeeze in. The suspensory ligaments are loose because they're not really needed anymore, they're just lying there loose. That causes the lens to be squeezed in, so it becomes shorter, but it bulges out and becomes thicker. The fact that it's thicker means the light rays can be refracted more, and they're going to be focused then. There's a for this changing the adjustment of the lens to focus on light rays regardless of whether they're close up or far away. I mean, you can be sitting reading a book and then you can look out the window and you can focus within a split second on something that's, you know, at the end of your garden or half a mile away. And so accommodation is the word. In this case, this context, it's the word that means that your lens can adjust its thickness to focus on objects of varying distances. So I know it's a word that you use in other contexts for hotels and bed and breakfasts and somewhere to stay, but you need to know that accommodation in this context of the eye is the ability of the lens to change its thickness to focus on objects at different distances. Okay, we'll leave it there then.